what you will going to do next when you are joining to an organization. So in a infrastructure, one of the thing is again networking side. Network security is very important. Okay. In the security side, you know the firewall. So people use firewall. What's inside a firewall actually? So what's in a cloud, or maybe it's in a firewall, or maybe software file. So different way we are trying to protect from unauthorized access. So you want to protect your network, your whole network from unauthorized accesses. So in the firewall or in the router, in the system, we create these kind of rules. We create a kind of rules. To understand that rules, it's very simple. I'm muted or you're not muted. My voice is, are you able to see what I'm saying? Is mind. Okay. Are you able to hear, right, guys?
Yes,
Yes, sir.
Well, so to enter into my network, so either you enter through a router or through a firewall, right? So from outside, we are getting in it. So here it is two-way communication. One is from outside to inside. Second one is inside to outside network communication. In generally, anybody can go to reach any network by going outside like this. Means if I access google.com, I can get a google.com information. But google.com want to come to communicate to my network, they can't come themselves. Okay. So leave it, we'll keep it that side one part. Okay. Here it is. So many people will access. I want to protect my network. Only accept this network. Don't accept other than this network. Only accept, take the communication from this particular network only, not from anyone. Okay. So like that, you can create a rules. So here we use yellow or deny kind of concept. Yellow, deny. Yellow or permit. Another word for yellow is permit. Okay. It is in a ACL, access control list. We implement this ACL in our routers or firewalls. What is ACL? Is simply a list. ACL, access control list. It's a list. What is a list? List of rules. Okay. What is ACL? Access control list. Okay. What is contained? List of rules. Yellow or permit or deny. And or deny list. List of rules. Okay. List of rules are there. And this list, when you're preparing a list, for example, the list number is 1. You can create list, rules list. So list number 1, list number 2, list number 3, like that you can create a multiple list. Okay. So in the list, we'll specify who are allowed, who are not allowed, or who are permitted, who are not permitted. Network-wise permit, host-wise permit, or protocol-wise permit, we can able to provide it. The rules, again, yellow or deny list. Okay. In the list, again, in the list, we specify which is allowed or permitted and are denied. And are denied, which is based on network. Network means based on its network ID. Host ID means system, protocol, or port number. Okay, we can allow or deny those. Next. Okay, so here it is. I'm creating a list. Okay, my list number 1. In the list number 1, I said permit. This network, for example, I put a 192.168.1.0 network. When you say network, you have to give like this. Okay, permit. Okay, so when you say permit, there is an explicit deny also there. So I'm giving lot of permits. Permit 192.168 192.168.2.10 0.0.0. Allow this particular host also. Allow access for this particular host. Okay, 0.0.0 represents host ID. Okay, not network. Permitted. Denied. Okay, there is explicit deny, means when are you given a certain permit, only permit, automatically there is deny apply. Deny any means do not allow anything other than this one. 1 second. Today again started disturbances. Okay, sorry. Where are we? Okay. So what happened here when you put this kind of list? For example, there is a request. If there is an incoming packet, with an IP address of 192.168.1.20 from this IP 192.168.1.20. That is a source. Came to your system. Check in the list. Okay. Is it allowed? Yes, that entire network is allowed. Yes, yellow. You can come inside. Okay. And another IP. So 192.168.2.10. Okay. This from here, from this PC, we are getting a packet. Okay. The source IP is 192.168.2.20. Let's try to allow getting inside our network, and it will check the ACL list. Is it allowed? Yes. Enter. And another 170.16.2.5. Is it in the list? No. Is it in the permanent list? No. Then deny. Don't allow. Okay. It's a list, guys. Think like you given a list. In the list, you specified if this person, you given a name of the list. Like if this person is, you specify the person name. If this person name, the person came, allow, permit. Or if the person belongs to this group, allow. Other than deny. Okay. So either you specify the person name wise, like a host ID, IP address, or a group name means network ID. Like your give, permit or deny wise also. So I'm talking very simply permit wise. So in a permit, you are specifying this IP allow. This IP belongs to this network. So then allow. This network is allow means any IP address belongs to this network allow. Other than that one, deny. This is how the ACL works. Understand, guys, what is how the ACL works? Permit and deny formula.
Yes, sir.
So again, access control list. It's a list of rules. Permit rules, deny rules. Okay, also there. So while you are giving rules, when you are creating these rules, you should be carefully, we have to design these rules. Carefully, we have to design these rules based on a priority order. Also, we have to design the rules. Priority wise, you have to create it. And we can't edit this list. We can add one more rule you are adding, that will be added to the append to the list. The thing is, if you are adding one more rule, it will append to the bottom of the list. Okay. So append means already rules are there, it will add it to the bottom of file. Okay. If huge changes are there, definitely you have to remove entire list and recreate it and do it. Generally, what people will do it, they copy entire list into a separate file. Okay. They edit in the file. They remove these entire rules. Again, put it back from this one. That's the best practices. The rules already existing. If you are adding one more rule, it will adding to the bottom. Sometimes it will, the new rule will disturb the actual one. It may be compromise your security. Possible there is a compromising of security. Okay. So then what you will do? We'll take all the rules, copy into the notepad, edit in the notepad. Means what is the new rules are there, changes are there. We'll do it separately and remove the list. Again, we put our new list into it. That is the best practice in the generally in our organizations. Of course, to make it better, so we are getting now, it's a named access list we are getting. Earlier numbered access list, now we are using named access list. Named access list we can able to edit in between. Of course, that is also we have to follow a technique to do it. But this is, what is this? If you are change something, it is, again, you may get a problem. Okay, guys, you are writing it denies. Earlier is a simple one line permit, deny. but you're telling multiple things like a deny this particular network, deny this particular network, deny this particular host. Like you're writing a deny. And you said permit this particular network, permit this host. So what happened? Okay. What happened here? So there is incoming packet came to your network. Your router will verify or your firewall will verify. Okay. One by one. It check one by one. Is it rule belongs to this one? Is network ID same network ID? Incoming packet, same network ID. Deny, deny. That's it. Not allowed. Okay. But it's not like that. It go to the next. Is it any possible to allow from here? Verify. Is it this network ID? No. Then check it. Is it here? Is this rule? It verify each and every rule. So one incoming packet, check one by one rule. As per this rule, allowed? No. As per this rule, allowed? No. As per this rule, allowed? No. As per this rule, allowed? Yes, go. Okay. Okay. So which list you are in? It's like a voter ID list. Are you in this list or next list? Okay. Are you can able to vote like this? So again, when packet is come to your network, your router or your firewall, open the list and verify from the list rule number 1. Matches? Okay. Permit matches. Rule number 1, permit matches. No. Then go to the check with rule number 2. Check with rule number 3. Check with rule number 4. So each rule it will verify for permit purpose. Okay. Permit purpose. Whenever it is find the permit, so then it will come inside. So that's why when you are modifying or adding new rule to your existing rule, maybe it is compromise your security. So carefully you have to do it. Okay. That is we have to keep in mind. Okay. Okay. That's when you are doing this access control list. Again, here two type of ACLs are there. Mainly one is standard access list, standard. Another one is extended. In a ACL, standard access list. Another one is okay, standard. Another one is extended. Extended access list. In the number type, so number between 1 to 99. So it means when you create ACL and you specify the number between 1 to 99, it is standard access list. Okay. In extended access list, if you specify the list number between 100 to 199, it is automatically extended access list. In standard access list, you can based on this work based on the network ID or host ID wise. Means host IP address. Means single specific host you can specify or entire network you can specify in the standard access list. Okay. And mainly source wise. Source based. Okay. So it is works based on source IP, implement close to destination. Okay. So we'll implement near to the destination. Next, extended access list. Okay. It works based on network IDs, of course. Network ID, Host ID means IP address. Okay. Port wise or protocol wise also it will work. Mainly protocol or port wise it works. Okay. Both source and destination based on source and destination IP, source and destination protocols. Destination. This is implement. Close to source. Okay. So this is ACL. Okay. So standard ACL, extended ACL. One more is there that is called named ACL. In named ACL, again, we have a standard. We have a standard and extended ACL also there. What is this named ACL? So instead of giving number to a list, we give name. Instead of giving number to ACL list, we give name to ACL list. Okay, so we can give a name. Can be edited after implemented. After implemented, a named access list can be edited. Okay. After implementation, again we can add a new rules in it. Okay, in a numbered access list. In numbered access list cannot edit list. New rules are appended, not in between. New rules are appended, not in between. Okay. Here one star point is also there. Okay. ACL. Step 1. It is create ACL list. Second, apply the ACL list on interface. Okay, on the interface. That is very important. Third one is we know test. Okay, third one we know test the connection. Okay, so again, guys, look at this ACL. This is a router. There is an interface, right? This is generally WAN connection. For example, it is a WAN connection means serial 0 by 0 by 0 connection. And this is connected to a network. For example, this is gigabit 0 by 0 and this is a connected to a network. Now, you created a ACL list you are created. For example, list number 1 and you specified the rules. Rule number 1, 2, 3, like you specified the rules. Okay. But where these rules are applied? Where these rules are applied? For example, you take one example that is, okay, permit. Okay, permit this particular network. Permit this particular network. Look at here carefully. So I am getting an incoming packet from 192.168.1.20. From this, I'm getting incoming packet. So it came to your interface. Okay, this is incoming packet. It enter into your router. Okay, so where do you want to stop? You want to stop at this place or this place? What is the difference? Let's see. I have another networks. We have separate networks also there. Okay, so there is other devices are connected. Okay, so these are some other devices are connected. This is one network. This is connected to gigabit 0 by 1, 0 by 0. If I implement this rule on this interface, so what happens? If I implement this rule on that interface, what happens? The rule is implemented on this particular interface. What happens? Whenever the packet comes, sorry, where are we? It is permit, right? Permit. Think like this network is denied. Think like this network is denied, or this IP address is denied. Okay, denied. So packet enter into your router to this interface. Interface open this access list. Interface open this access list. Is it in the what is check the list? Deny 192.168.1.20 is denied. Denied. Yes, you are not allowed. Then it will close it. So means this device cannot communicate this network and this network also. They cannot communicate it to this network and this network also. It cannot communicate. Okay. In case if I implemented this rule, okay, if I implement this rule, means access list one rule, I implemented on this interface. The packet will reach, the packet will come to the router, and if it is try to enter into this network, it blocks. If it is trying to enter into this one, it allows. So important in the ACL, not only creating of ACL, which interface you are going to implement that rule. So on interface, you have to implement it. Here also there is thing, in and out. In is there, out is there. Actually, you are protecting your network from incoming packets. Then what you will do? You implement in. You are putting out. Means when this device is trying to reach the destination, here only it will verifies, not allow. In means for incoming packet. Out means outgoing packet. Guys, understand this ACL concept, interface concept? No one is speaking. If you don't speak, it will take a lot of time to explain. See. Because I thought you don't understand and see, forget. Yesterday, I created this simple topology, guys. Okay, it's a sample topology I created. So I take one router, another router. This router name is R1. This router name is R2. And this interface is also configured. Okay, and this is 192.168.1.0 network. This is 192.168.2.0 network. 172.16. network, 170.17. network it is, including IP addresses also configured inside. Okay, but they won't communicate each other because we didn't implement any routing here. Routing is not implemented. So I'm defining a static routing on it. So in this router, already these two networks are connected. So this router don't know how to reach this network and this network. This router don't know how to reach this network and this network. So we are implementing a static routing on it. So very simple. Enable show IP route. So nothing, no routing implemented. Also better to show running configuration, guys. Anything is configured, only IP addresses are configured, nothing more. And one router is connected to two networks for this practical. And finally, we are going to configure terminal. Okay, what we will do? First is static routing, IP route. Other side, two networks, 170.16.0.0 network. It's class B. Okay. 200.10.1.2 is a exit router. Same. This is 17. Two networks are there. Okay. So implemented static routing. Save it. Okay. In this router, also we are going to implement. Sorry. Control Shift 6. Enable. So show running simple, no only IP addresses are configured and nothing. Show IP route. Okay. Show IP interface brief. Okay, IP addresses are configured, but not the routing configuration. Configure terminal. I'm configuring static route very small. So static route is very easy. What networks you don't know? 192.168.1.0 network. That's 200.10.1.1. That is next hop address. Next router address. .0 network 255.255.255.0 200.10.1.1. Same one. That's it. So IP route. See, there is a static route is added. Now, routing is implemented. Test the routing. Test communication from this PC to this PC. Yes, failed. Successful. Okay, this is same. And from here to here, yeah, successful. From here to here, successful. So the devices from here to there, there are communicating. Okay, there are communicating. Even you want to check in the simulation from here to here, the packet will send to the router. Router send to this router, and router sending to reach the destination. Now destination reached, again we successfully received our packet. Means communication is good. Okay, so here in this router we are implementing our ACL. Look at this R1, I'm implementing. What I'm implementing is here is we need a plan first before doing it. I'm yellow means I do permit this network to access, okay, your system. Okay, simple, only one line. Deny any. No others network allowed to access. That implementation is again on the serial 0 by 0. I will implement this rule. Okay. I will implement this rule like this. Okay. So what happened here? This is allowed to communicate these networks. This network not allowed to communicate. Means any other than this network not allowed. I am permit only this one, not anything. Even when you are connected, your organization network, okay, through WAN, but you should receive only packet from your head office only. What you will do? You are allow the specific IP or specific network only. You are not allow any other than that IP address. Understand? You are allow only the specific network, not any other source. This is yes, not only just our home lab kind of stuff. It's implemented and the other. Next, we started implementation. Yes, yes, also configuration terminal. Now to specify the access list. Access list. Okay, if you give a number between 1 to 99, it is numbered access list, standard access list. Okay, I'm giving my access list is number is 10. Sorry. Maybe I'm doing wrong. We will try. சொன்னான்க்கு நீ access list and permit. Again, what to permit? Any means all are permitted. Or you want to permit particular host or particular address like that. So permit entire network. This entire network I'm permitting. Okay, either you can press enter or you can give network wise. Means it's a class B wildcard mask. You can specify the wildcard mask or you can specify the enter button. So enter network, it will understand. See, I created access list 10. In the 10 permit this particular network. Again, same access list. List, it's a list number. 10 means list number. So I said deny. Deny. Again, deny particular host or everyone or specific network. I say specify any at this any. Okay. Access list created, done. Now you have to implement on the interface. So I'm implementing on my serial director first interface only. Okay. So packets will come to your main interface, right? So for on that one only I'm implementing. Okay. IP access list access group. The access list number is 1. You have to give in or out. In, because when packets are coming, I will check their IP address or network ID. Is it allowed? Yes, allowed. Not allowed? No, we can't allow. Okay, so that we are going to implement here. Simple. Hmm? Now we are going to test it. How to test it? Let's see. Yeah. From here, take the packet. From here, I want to reach here. Successful. From here, I want to reach this network. Successful. From here, I want to reach this network. Fail. Again, try again. From here, I want to reach this network. Failed. Okay, we use a simulation. So from here, I want to reach this destination. Packet sent to the router. The router knows where is that network, so it will forward that to that router. Router C, first router opens your access list. Is this IP address or network is allowed inside? Yes, it is permit, then it's forward. Okay, finally, we done communication. Successful. Same thing, from here to here. Okay, packet send. Yes, it reaches to that network. See what is saying it is? It opens access list. In the access list, this is not allowed. This IP is not allowed. It rejected. So we get back that packet. Hence, we are getting out. Okay. What happens if you are communicating from your system to there? From here to here, communication. So you are sending the packet because you implemented only in, not out. Means you said you cannot go, but that is should not come inside. Okay. We didn't say like you can't go out of your house, but your friends are not allowed. Okay. So like that. So you reach the destination. But again, destination want to give you a reply, right? So now destination try to reach you. So where it is blocked, here it is blocked. Okay. So that is how it is works. This is a simple ACL kind of stuff. Then we'll see the small extended access list. What is extended access list? Not only network or host, also certain protocols are not allowed to access. For example, I have a server. Okay. In my network, I have a server. It's connected to my network. So think like it is a web server. Okay, it is a web server, HTTP on, and I'm going to edit some files. You can take index.html. Okay, so I'm getting where I want to put this line. Yeah, here it is. Welcome to center HTML page. Center. Here I put it. H1. NTTD. Which network it is? 192.168.1.0. Okay. Slash H1. So that word will be visible to everyone. Save it. Yes. Again, HTTP. Both HTTP like this is. From this network, I am trying to open. From where? From here. That web page. Once 192.168.1. Oh, this is not having IP address. Forget. First, server need an IP address. Without IP address, how it will be communicated? Something 80. And the gateway. So this is our server IP. Port number is 80. We try to reach the system and the protocol is HTTP. It's in a simulation mode. So change it to real-time mode. See it is. We got this one entity 1.0 web network. Okay. You're successfully able to access it. So from here, we can able to access that website, right? So we can restrict it. It should not be accessed. That web server cannot be accessed like that. What happened? This is voice PF. It got closed. Again, login. Why it is closed? Suddenly it is somewhere like that. It is crashed type. Already. It's open. Waiting. Open. Yeah. Okay. What I want to do is, where is that server? So this is a server I want to put. First, you should give IP address to this server 192.168.1. Anything you can give 80. Okay. And IP address 1.1. Okay. This is just a machine. Sorry, what we are doing is, go to services, HTTP on, I'm going to this, okay, I'm adding one extra on it. That is that H1 entity, okay, that server, one, that's H1, let's save it. So try to access from other router. Before that one, we should connect it. So I'm connecting my server to my switch. Okay. So in this network, there is a web server. I'm trying to access it from other place. One 190.168.1.80. Request timed out. No problem. We can try. So we got it. Entity, web server 1. Other things are got changed, but it's okay. We are able to access website from this network. Okay, this web server. Okay. What we are going to do is we are implementing access list, extended access list on this router. Earlier what we are implemented standard access list. Now we are going to implement extended access list. What is implementation we are going to do it? That's important. Okay. So 192.168.1.80 system is a web server, right? So people cannot access website. Okay. It's a web server. You cannot access the website. Or you can permit only website access. Others we can able to deny. That also we can able to implement. Okay. So we'll see how it is will work with that one. Okay. So one by one rule we will implement it. Access list. Again, if you want to create extended access list, it should be more than 100. Earlier I put a 10, now I'll put a 100. 100 means it is, I'm going to create extended access list. Which one you want to do? Permit or deny? I want to deny. I want to put a deny. Deny a protocol, IP address or TCP. TCP. Okay. From this specific IP address. Check it. From a specific system only, I want to block it. Okay. Deny access this. Answer. That is 11. Okay. Clear wildcard. So class B. Okay. Equals. Equals. Equals to which protocol? Either you can say port number 80 or specific protocol number. You can say www or you can simply say protocol number. Okay. Any host or specific host. Specific host or any host. I'm specifying my host. Okay. I'm specifying my host. Incomplete command. Again, for this also I have to tell. No. Specific host means all are zeros. Okay. So it is what I done. I created an access list, number is 10. And I specified a deny. I specified a deny. In that deny, I said 190.170.16.0.1 from that IP address. Do not allow port number 80 request for 192.168.1.80 system. Means it can do 80 requests for any other systems. If you have another servers are there, you can allow the request. Okay. So that is, of course, not only creating and also you have to implement. Guys, when you give a deny, obviously there is an explicit deny will applied. Once you say deny this, everything is denied automatically. Once you say this is permit, other things can be deny or permit, where we can't judge it. But when you say deny, everything will deny. So compulsory you have to give permit access. Permit TCP, okay, for everyone, for anyone, can access apps. Okay, like this. So permit any. So it's a simple permit any, permit TCP any, that's enough. So I put a permit any, all things can be able to accessible. Now you have to implement on the interface. Interface serial 0 by 0 by 0, IP access group number is 10 in. Now we are going to test it again. What is this? Where is mine? Yeah, here it is. Again, we are testing from this 1.11. We're trying to open that web page. Suddenly, what happened to my applications? This is that system 192.168.1.80. It is accessible. We have done something wrong. It's accessible from here. It is accessible from here also. Okay, something we have made and run. So either you have to do something. Exit.
Sir, we give only PC 7 deny.
Yeah. We are giving deny to only
particular device only.
particular device only.
Mm.
For this only we are giving deny.
Yeah.
But what we have done the mistake here, maybe this is access any. This is the column possible. So again, show running. So what are the things you have done? It will be shown here. Okay, look at that one. Then configure terminal. You have to remove complete configurations. Means no access list. This one. First you have to remove the configuration, then second configuration also. If nothing works, you have to restart the router. Okay. Again, this is a configuration, right? Access list 100. Deny request from this specific PC, or will take we are deny and as well as permit. So maybe because of it is working, and as well as when I'm giving, I think I given instead of 0.0.0, I given everything. What we will do, deny complete network first, then we'll remove and we'll check it. Okay. Complete network, deny access is particular website services. Means they can ping and all they can do it, but web access we are denying it. So this particular system only. Yeah, when you say host, it is enter only. I said host now. That's it. You can simply enter. Just I put enter and we'll see the request. So you are trying to, it is getting request timed out. Try once again and check from other system. Check it. From both systems, we can't access. Okay. And we try ping to the remote system. Okay, you are unable to access, then you have to do pinging. But what it is you are getting, destination host not reachable. But we didn't deny that one. No? That's explicit deny. The problem with this explicit deny is also problem. That's why I allow, but it is allowing everything. Okay. When you say deny, okay, explicit deny will be occurs. I'm removing this rule and I will change the pattern. We'll see that. Now, okay. Again, I'm creating this rule. When I say rule is not there, I remove the rule. So try to ping. Now you are able to ping. Okay. And also try to access that website. See how much it is. Now we are able to access. So this rule is working. But what it is doing is it's stopping everyone. Every communication is stopping if once the rule is available. Then what we are going to do is we are specifically telling to whom it should be allowed, it should not be allowed. For 11 system, I am permitting. What I said, permit this system. In 0.0 means you are specifying this particular system, not entire network. This particular system is allowed to access through this one, port number 80. Permit. So I'm giving permit to a system to accessible. Okay. So only we'll implement permit and we'll check it. This is we given permission. There it is showing request timed out. I given permit, not a deny. Yeah, this is request timed out, we can understand. Can we ping? So because of this extra deny, means automatic deny kind of stuff, it's also working. We can not only this one, guys, also we can restrict. Also we can able to permit or deny EIGRP means particular router or particular way that those advertisements should not be done. Okay. Ping is working. That's why implementation server is also working for 11, for 12. Pick the ping. Ping is working. Either it is working for both or not working for. Uh, what I'm going to do is show running configuration. I'm going to remove all the paths. This no, all the list I'm removing. One we are understand that standard access list came easy. Okay, so we permit one network. That network is running. Remaining is not working. Right, like. But what happened to this? This is when we once this explicit deny means when you given a permit, automatically in backend, it's denied. Okay. So here I am keep on permit. So then there is a also column sucker. So I removed everything. Okay. I removed everything. And this is one more server. And this is image. Now go to this. Sorry, this index. Put another H1 entity app server to dash H1 save. Okay, everything is fine. No ACL, nothing is there here. So everybody can able to communicate to everyone. Okay, yeah. From this to this, everyone can able to communicate to everyone. Even they can able to communicate this server also. They can. This extended access list can implement any of the network, either this side or this side, source or destination side, you can implement. One second. So again, I'm implementing this access list. One more we forget to stop implementing on the interface. So that is also we're going to see the interface. No, and see on the interface, I implemented this one. Look at this. So that's why compulsory see the show running configuration. So you can understand what configuration you have done. So now no configuration at all. So I am doing extended access list. Okay, again I put a 100. I said deny any, deny anyone, deny, sorry, TCP, anyone, deny. Hmm. Equals port number 80 from, okay, from anyone, deny accessing port number 80. Okay, the destination, okay, destination is host 192.168.1.18. I'm denying anyone to access from here. This port number 80, the 80 that host through web access, I denied. So this deny is always headache. But you must give permit kind of stuff. If you give permit, then we will understand that which one is working, which one is not working. Okay. So you have to give permit, not deny. So I'm giving permit. Anyone can access this server with the port number 80. I'm giving permit. Okay. I'm giving permission. Anybody can access this part. So only permit. And I'm implementing on this on IP access group 100 in. Okay. I'm giving permission, not a deny. Remember. I have a two web servers. I'm giving permit. The request go to that and ask for the access request timed out. Try this one, second one. I said any network. So problem with this extra deny means you given a permit, but automatically you take a deny uh, in the back end. We give why I'm doing this is really giving 1 second, guys. Give me 1 second. Just wait and relax. Just we are checking access only. Deny IP. Okay. Deny IP access from 192.160, this one, from this particular system to this particular system. Okay. This is just only IP base. Okay, again we'll remove that rule and we'll see this. First we'll test basic permit. Remaining all communications are permitted. Again we'll remove this rule and we'll test it. So what I said, from this IP address should not communicated to this specific system. Specific system. Okay, we'll open this. Try to pin 1.11. Okay, 1.11 cannot communicate. What about 1.12? Yeah, we can able to communicate. Means only but butler system we can't able to communicate. This is how we can give. Even 80 also we can able to communicate. Then that 80 port number, that's a web server, we can able to communicate. Sorry. Okay. So this is what we have done. Just understand what we have done here. I allow everyone to communicate and not communicate this specific system from this system. Okay, from this system to this system, communication is stopped. Okay, and I'll allow everyone to communicate. Only this system to this system, communication is stopped. Can take a simulator also. Take from here to here, packet send, and this see not communicating. From other systems, from here to here, they can communicate. Okay, they can communicate. But again, from this system to other systems, they can communicate. Okay, the specific system to system communication is we stopped. Okay, again, I'm removing that rules. Okay, and again, we'll recreate it. So I put a no to remove these rules. And why I'm removing? Main problem is this permit problem. As I said earlier, when you create some access list, so compulsory, you have to keep it aside. And if you want to change anything, you have to remove everything and reconfigure based on why? Because you are already given permit. Again, I given something deny, that won't occur. There is a permit, there is a deny, like a helmet rule. Everybody must wear the helmet rule, otherwise you can't come to the road. That is the rule. Another rule is, okay, if you are not wearing the helmet. Again, there is a helmet rule. And there is a confusion. If you don't have a license, don't come. But without license with a helmet, allow. Like that, it confuses the system. is really yellow or not yellow. So that's why you have to create from observations. Access list. One more is where that is not have to tell deny TCP Butler host 170.16.0.11 or Butler network. You can take complete network, this entire network cannot access web servers to Butler system or any destination with the port number 80, they can't access. Okay. Any port number with port number 80, this network cannot access or specific system. We done same thing, but we got a lot of problems on it. Okay. This is our web server. And permit IP any. We will check it once again. Already it is implemented on this interface. We'll check this communication from our PC. Open command. Can we communicate to this 12 dot? Yeah, we can able to go to 12 dot. Try 80. 80 can also we can able to reach it. No good, very good. Then try open the website. Earlier for example, we are done that is we block the ping command. We block the ICMP protocol, means ping won't work, but website it works. So different ways we can protect our network. It opens. What we do? Why it is making me this? I specifically told this network should not be allowed to communicate to this specific PC with port number 80. Then I given permit all remaining communications. So remove the permit. Try. Okay. Accessing even I put a deny also is accessing. Anyway, it's already one, almost 10 to 1, guys. Just wait. Okay. Then we'll go for lunch. Then we'll discuss one small topic that is called a NAT. But we should be completed by now. This is unexpected results we are getting. I have already pre-prepared, so but just I want to show you how to do it, and this that's it is giving me a problems. Now this time I'll give permit. Mhm. When you're given a permit, it is not permitted. There is one more problem, that's a port wise. Earlier it is allowed, now it is automatically allowed. Earlier is denied without thinking, it is denied the request. Yeah. See, when I given a permit, it's not permitting. When I given deny, it is denying. Where I done mistake, I am not understand. Not at all permitting that network. I'll figure it out later. Now it is accessible, but we are trying access this one. There is 2.80 is also there. So we'll try 2.80. 2.80 is also accessible. You try from other network. We're trying from different network. In communication is there. Working is accessible. It is permitted. It's working. Okay. From what about other system? I'm trying from this system. Array. We are in a hurry and this is not cooperative now. Serious. Go ahead. It's open here only. Which instance it is? This instance only. Right. Waste. We deny everything. We permit only one. Remaining are deny. But this explicit deny permit conflict. Permit deny conflict. So it's very difficult. Maybe interface configuration problem. Try this one now. Huh? Okay. Okay, go for lunch, guys. And only one standard ACL. It is working just for one part only. But extended ACL, it has to work. That's I done so many times. Generally, I'll configure and keep it aside. But now, what are I implemented? It is not showing that kind of stuff here.
So in Google, it's showing only to mention wildcard or mask.
Wildcard.
Yeah, yes, sir.
The wildcard part is okay because I allowing enter this network.
Yes, sir.
Yeah, allow. I'm permitting enter this network to access this web server with port number 80. And where is the problem occurs? When I given only this statement, this explicit deny, the deny is saying that no, you are not allowed to access. Okay, without doing it. For example, this is where we have done wrong. Actually, it should be in, not out. So we will filter at a incoming time only. Today is a Friday. That's so IP running configuration. Yeah, see, we deny is there. Okay, there are a lot of conflict is there between this and this is allowed here. That is deny there. So there is a conflict between permit and deny. Okay, it's a conflict. It's created like this. Then go to this running. That list is removed or not? Yes. Okay. Access list 100. I better to take one more separate one. Okay. So deny what you want to deny. Deny IP communication or ICMP communication, any internet protocol. So you can deny ping, or deny some web access or a ping access like that also you can tell. So TCP, deny TCP, any source host from incoming packet. From an incoming packet. Two, not like this. I'm denying request from this specific host. Specific host means this is wildcard. And what kind of deny it is? Any request? Any request? Okay. Or specifically are allowing something, any request or specific protocol. You can say any request. Any request. Any destination host. Any host. So what I'm doing is 192.168.1.80 host. If it is a host, then equals. Maybe I'm doing wrong from starting like this. Deny request from this butler 0.11. Okay. But it is explicit deny will be applied. Means once you given deny, it's deny for everything. But we test normal means remaining all will be communicate as per my previous one. Okay. See, we can't communicate to anything. So what we are doing is, so once you deny, everything is denied. You have to give permit for remaining things. Okay. You have to give permit for remaining communications. TCP permit any source to any destination. Any source to any destination, you are giving permit. But once you given a permit, what it will do? It accessing everything. When you given a permit, it is still not working. So you have to test from other system also. MSL I'm in home. I given permit for everyone, but still not communicating. See? They're not communicating. Even I given permit any. Instead of permit TCP, I permit any protocol, IP from any system to any system I'm permitting. Now we'll see the devices will communicate or not. Okay, all are communicating. Okay, all are communicating. From this to this, all are communicating. But what we denied from this system, request for this is denied, but it is not denying. There is a conflict is occurred between the deny and permit. Okay, between the deny and permit. So there is a conflict is occurred. Sixteen matches. 16 matches. Okay, we'll try once again. Already I'm in a this, so it is showing delay. It is. From 6, it's accessible. Accessible. Nothing works here. I think still I'm doing somewhere mistake in this configuration implementation. Okay. So afternoon we'll see, guys. We'll figure it out where we are doing the mistake. Already it is one minute, I know where is the mistake. Here also I'm doing some mistake.
Okay, sir.
That in and out is actually initially I got confused in earlier days of when I learning that time. And later also when I practice random time, I'm gonna get a dot. It need a router restart. Okay, so no problem. We need to restart our routers, then we will implement. So we'll see you in the afternoon, guys. Lunch 2:15, guys. People, everybody must come at 2:15. So we'll start by 2:15 to 20. Okay, compulsory. Okay, I will re-explain this access list and all, and that also. Then we'll go to the next any security related concepts. Okay.